the seismic radiation that they run through the Earth from the top, okay, goes through faster than from the side. This makes sense because this right here is blocking it, goes into the cube, then is blocked on the other side. So this distance here is a lot slower than the cosmic goes through this way. Now you're going to say, well, what do you mean? Why? If that says if that's in the middle of Earth, what the heck is this? You know, well that's this. You know, the same thing. There's the shape. See it? So you know that the Earth is turning, and that's the shape I say is the middle of the Earth. And honestly, they don't know it. I've read all this research. Okay. This is, you know, seen through the Hubble-based telescope. And what I saw about this was that, you know, that's what I drew on the board, those two circles. But I saw that there were two circles. There was one here and one here, and then there was a big one that went around the outside. See it here? Another one around here. So I thought, I'm going to design and try to find out what the middle of the Earth looks like, because I know the size of it. It's 3, and I know the whole diameter of the Earth is 11, and I'll show you how I know those measurements. I put that together into this drawing. And this drawing is made completely with just a compass and a straight edge, no measurements. This is exact, and this is what's amazing. I've been able to go from 3 dimensions to 2 dimensions and keep them consistent, which very rarely happens. This distance right here is 3, and this distance is 4, and this is 3. And this from here to here is 11. And if you take it like the Egyptians did, they take a square around the Earth, then they go to the middle of the sun or the moon and draw a circle. It squares the circle. The circle and the square are exactly the same perimeter. The distance around the square and the distance around the circle are the same distance. So if I run 11 miles this way and this way and this way, that's 44. And if I measure the circle, the diameter of the circle is 44. It's called bringing heaven and earth together. That's the circle and the square.
Wait, you mean the circumference, not that?
But what?
You said the diameter of the circle is 44, but you mean the circumference.
The diameter what now?
You said the diameter of the circle is 44, but you meant the circumference, right?
I'm not sure if I know what you're asking.
You said that if you do 11, 11, 11 for the square,
Yeah.
right?
Yes.
But then the circle's circumference is 44, not diameter.
Okay. The square is 11. This is 11. The diameter is exactly 11. Okay? So the radius is 5.5. So this circle and this circle are coming off the vesica, or this drawing right here, this thing right here, is coming off this square, off this cube, off that shape right there. Okay. And so this is how the Egyptians did. Maybe this will help. The Egyptians did it like this. They said they used a 3, 4, 5 triangle. This right here is 3. It is on this drawing too. And right across here is 4, and the distance from there to there is 5. So that means that this is 4, this is 3, and this is 4. That's 11. And they found out that squaring the circle was based on the Egyptian triangle. I found out that squaring the circle in the earth was based on the cube, which is those two circles, which also I found here. So this could be, this could be an interpretation of maybe how the earth is formed. Who knows? And of course there are really 2 cubes, which is known as a 4th dimension, and this is known as a tesseract. And this is how this flows. This is how those rings flow together and weave in together that I studied, and that is if you study these forms as a meditation, like a mandala in the past, this is what you would have to study in your mind, is where these interrelate. And you have to remember that this is polarities, because there are 6 points, or 6 faces to the Earth, or the cube. So I have made them into, I have made them into polarities. Okay. Your orange, if I can get this back. All right. Your orange, the opposite is blue. Yellow, purple. Yeah? Those are polarities. So what happens is when you study the polarities and they start to weave in and out like that, what happens is what happens in the center of these circles, and also what happens to your mind when you run this in here. Does it come out here, or does it go under this, or what? And these are the type of lawful transformations that we need to study now, because they're not unlawful, they're lawful. And this is basically what's going on in the earth. This is also what goes on in the heart. So I made this three-dimensionally. Here it is. I don't know if I answered your question about that circle and the square, but I'll answer it for you. This is what it looks like. That's what that form looks like three-dimensionally. So you can see that this circle is the opposite of this one. So, and in the middle is the 3, and the outside is the 11, which is the size of what you saw two-dimensionally. This is three-dimensionally. Now you're going to think, well, my gosh, is he saying that's what's in the earth? Well, I have no idea. But neither do they. You know, maybe in the future, if somebody looks at this thing, maybe they'll see, hey, maybe there is some relationship between here, the magna. Already, Rilla Steiner is saying there are 9 layers in the earth. Okay? And if you count those rings, there are 9. And I'll show you what I mean. There are 9 rings. So if you count them, I won't do them all for you, but I'll do some. 1, 2, 3, 4, 5, and on, you'll get 9. And right out of his literature says that there are 9 layers to the earth. So let me go back to the very beginning here and show you that this is the 5. This is the 5. This is the 4. And this is the 3. This is the 7-sided form. Okay. Only other thing I have here, no, I think that's all. That's all I can tell you about the earth. So I left some time for questions. So did I answer your question? This distance here, they ran as 4 inches. They ran it up 3. And then, of course, if you connect these two, which is the Egyptian triangle, that comes out perfectly 5, 3, 4, 5. Okay, this isn't quite right. It's probably more up like that. And then they did the same on this side. 5, 3, 4. It works perfect. Then they closed this together and they put another sphere. They took the center of this and they ran it around the earth, or this circle, back to the center. And they found out that this square, bad color, this square has a perimeter of this circumference.
The largest circumference.
Right.
Largest circumference.
Not the smallest.
What's that?
The largest circumference.
Yes.
Not the smallest circumference.
Yes.
Okay.
And that's what this is. I didn't do it this way. I started out any size circle you want to set your compass. All you have to do is run this here, put the compass here and run a vesica, which I'm going to do in a workshop while you're going to draw this. It's so simple. You draw a circle here. You go on the other side, draw a circle on this side, just like I did at the very beginning. Except that the next circle comes at the top here. This is in the book. So you have to remember that I'm not here to prove anything. What I'm trying to show you is that a way of thinking okay, if you take an idea, okay, and expand with it, you never know where it's going. Listen, when I started this, all I wanted was a seven-sided form. It had nothing to do with the heart, it had nothing to do with the earth at all, nothing. But then, 10 years later, I'm still doing it. So that's kind of what this is. And that now, you see, the Egyptian triangle, the Egyptians, okay, they started from the outside and worked in. I didn't. I started from the inside and worked out. And that's what's different. Remember how I said that the outside didn't work when I made the 7? So I decided to go in. That's what I did with this. I decided to go in and work out. That's a reversal. Yeah.
A couple of things that have come to me as a
Okay.
watching your lecture. I see a Chinese knot.
Do you?
Yeah, and I make them.
Oh my gosh.
And it's really,
Marine animals, which is found in diatomaceous earth. They use to clean pools.
Radiolarians and Nessalarians.
What's that?
They're called radiolarians and another kind called Nessalarians.
That's right. Well, Julianne, what do you think? Thought you'd have a question. No? Okay. Yeah.
So what was the, when you did the 2 circles and you had the intervening section with the root 3 in the middle and that
Yes.
whole thing?
Yes.
Where were you going with that?
What?
Where were you go, like, well, how does that interrelate to this whole?
Root 3, root 3, root 3. Root 3, root 3, root 3.
can you show that to us?
Formative forces.
Show us the root 3.
You see, because if you take this guy here, if I can find him, here he is. Here's the cube inside the earth, which is based on this one. 1, 2, 3, 4, 5, 6. There they are. 1, 2, 3, 4, 5, 6. That's how I got the cube. One's missing here. So the 6, 2-dimensionally, is a cube 3-dimensionally using root 3, which is formative forces.
So you're saying that the vesica is the key to understanding formative forces?
The vesica is what?
This vesica form
Yes.
has been so much part of, say, architecture and also in painting.
Oh,
This form, and you're showing it dynamically in architecture of the earth, you're showing that the vesica is the geometric principle, but you have to imagine it in movement.
That's correct. See, that's, the real Steiner calls that the etheric. And that's right. See, this is a static 2-dimensional. This is 3-dimensional, okay? And I can put this into movement by spinning it. And that's where the cube starts to get into this shape, yeah? This is the cube spinning come to rest. This is form come to rest. That's what they call this. And this is all geometrically perfect. I did it. Because when you spin the cube, the triangle turns into a circle. You saw that before. But this is 3-dimensional. And what's so amazing is that because the cube has a triangle, and at the bottom of the cube, the triangle is turned this way. So the point here hits right in the half of the line. So that means that if I connect from here to here, which is 60 degrees, if I connect this from here to here and do it all the way around, so it lines up with all of these points, because I know it's off 60 degrees, that's how you get a curve out of straight lines. That's a curve. And that curve is shown to you in actuality. I could draw it and everything, oh yeah, sure, but this is real. And then, this is fantastic that this does this, because this is root 3. This stick I'm holding is at root 3. There it is. Now, if I put it at root 2,